Circles and ellipses are very similar. As a matter of fact, we can think of a circle as a special case of an ellipse. So I'm going to do these two together. If you look at this graph here, you'll notice that this equation tells us the two most important features of a circle, which are its center and its radius. A circle is defined by its center and its radius. The center here is 1, -2, and the radius is 3. So you can see from the equation, the 1 is the value I would put in to make this first parenthesis equal to 0. The -2 is the one I would put in for y to make the second parenthesis equal to 0. And 9 is the square of the radius. So this is the radius squared right here. So we could write just as 3 squared, which is often what we'll do. So if we wanted to write the equation for this circle, we would first locate the center, which is at -6, and this is 3, -6, 3. The radius here is 2, so I would write x plus 6 squared plus y minus 3 squared equals 2 squared, or 4. So that is how you write the equation of a circle. Very simple. Now, when I see an ellipse, the difference with an ellipse is that from the center, it doesn't stretch the same amount each way. If you look at this equation and you look underneath the x squared term, you see 16. And you notice that from the center, it stretches 4 in the x direction. So we could say the radius in the x direction equals 4, and this is 4 squared. We could also say the radius in the y direction here is equal to 3, and this is 3 squared. Notice this is always 1 when it's in standard form. This is always equal to 1. And the number, the stretch in the x direction will be always under the x squared term, and the stretch in the y direction will always be under the y squared term. The center here is at 0, 0, so notice there is nothing added or subtracted in the numerator. Now if we look at one that's off the origin, we see here that the center of this one is 2, 1, and it stretches 1 unit in the x direction and 3 units in the y direction. So we would write this in the numerator as x minus 2 squared over 1 squared, which is just 1, plus y minus 1 squared over 3 squared, which is 9, equal to 1. So that's all there is to writing the equation of an ellipse. I want you to notice that we could write a circle in a similar way. So if I took the previous one that I have up here, I could also write this, if I divided everything by 4, I could write this as x plus 6 squared over 4 plus y minus 3 squared over 4 equals 1. So we could think of a circle as the special case of an ellipse where the radius in the x and the y direction are both the same. So typically we do not write circles like this. We write the circle in the form that I showed you before. So I'm going to kind of erase this so we could see that this is just an alternative way of writing the same thing. That makes it look more like an ellipse. So they're very closely connected.